All right, better late than never. We're going to look at equations of tangents and normals. Now, we've spoken before of the slope of a tangent. We've spent the entire differential course or unit dealing with it, but now we're going to make equations of tangents. So just to bring back in a tangent and add on with a normal. So if we have a point on a graph, here we have a nice parabola in black, and we're speaking about this point that I'm coloring in right here. We know that our tangent just kind of touches the graph at that one point and skims it and creates this kind of situation. And of course, because this is a line, it's going to have an equation, y equals mx plus b, let's say, in slope-intercept form. A normal is another line, and the condition to be a normal is that you're running perpendicular to a tangent. So a normal at a point also goes through that point, and it would be perpendicular to any tangent we would make. So here's our normal. And it too is a line, so it has an equation in the same form. Maybe this one we would start by writing, and it doesn't matter, they're both equations of line, point slope form. Same, just another way of expressing a line. I'll use both in this video. So before we dive into it, we need to go back and think about what we need to make a line. We need a point and a slope. We can get the slope by finding f of x, the equation of the tangent slope, and then subbing in x equals minus 2. But when we want a point, we only have half a point right now. So I'm saying when x equals negative 2. So maybe let's just think about changing that and writing at negative 2 comma what? How do I find out what that point will be? Well, we're just going to find f of negative 2 using the equation we have. And sometimes this is best done first so we don't get confused as we start to have more equations of derivatives and we're making equations for everything else. Deal with it. All right, so if we do that math, we're going to get negative 32 plus 9 times 16. Sorry, I'm dealing with two things at once while making a video. Not a good idea. Equals 4. So what does that tell us? That we are having a point in question. Before we were talking about it being when x is negative 2, but now we're nailing it down and saying it's at negative 2 comma 4, which is an xy coordinate that happens to be on the graph. Okay, so I'm going to switch colors, and now I'm going to find m of a tangent. And we know that's equal to the derivative. So we go back to our equation, nice and easy with power rule. 5x to the power of 4. The 4 comes in front, it cancels. We're going to have plus 9x to the power of 3. Great. So if I want the tangent, I'm just going to keep writing it down. It gets away from people a bit. F prime of negative 2. So what is the value of the derivative at negative 2? Plus 9 times negative 2 cubed. And we do all that math, and we're going to end up with 8. So let's go to our equation of a line. What have we figured out so far? Our tangent will have an equation, y equals m, the slope, x plus b. So we've always kind of grown up doing it this way in Ontario. We start with y equals 8x plus b, and then maybe we take this point up here, negative 2 over 4, and put it in for y and x. Another way to go about it is to use that point slope form. Y minus y1, where that's just the y of a point, equals the slope onto x minus x1, which is that is just the x of the point. So looking at our point, we have y minus 4 equals the slope we just found onto x minus minus 2, careful, that'll become x plus 2. You can leave it like this. This is a valid way of representing a line. Or if you're really determined to have y equals mx plus b, you can just math it out. Y minus 4 equals 8x plus 16, rearranging y equals 8x plus 20. This is the equation of a tangent to the graph f of x equals x to the power of 5 plus 9 over 4x to the power of 4 at the point x equals negative 2 comma 4. So let's take a look at that picture. Here's our equation, f of x, our function, and here is the point, negative 2 comma 4. So we see that it is on the red function, which we needed, and then we see we create the tangent line, and now we know it's not just a line, we know that it's y equals 8x plus 20. Is there any other point on this graph that will create exactly the same tangent line? Nope. You might say that you could get over here something that kind of ended up looking parallel, and it would be y equals 8x, but as you can see, the y-intercept is going to be way down there, so it might be y equals 8x minus 16 or minus 18. It won't be exactly the same. I'm going to circle back to the normals, those perpendicular things, perpendicular to tangent things, and everyone's like, oh, what do you use that for? They have scientific applications, for sure. Google that if you want. All right, so what do we know? A normal is perpendicular to any tangent. So what will our process be? Well, probably find the tangent slope and then find a perpendicular slope. So we might remember that we had this formula where a perpendicular slope, that's my symbol for perpendicular, is equal to the negative reciprocal of your original slope. So basically, the slope of a normal will be equal to the negative reciprocal of the slope of a tangent. That's a mouthful, so I always am just like, flip the sign. So if it's positive, make it negative. If it's negative, make it positive, and flip the number. Find the reciprocal. So if we start with a slope of 2/3, and we want to find a perpendicular slope, we make it negative because it was positive, and then we invert 2/3 and make 3/2. Done and done without a lot of thinking. Likewise, if we start with the slope of a tangent, let's say, is -4, if we want the slope of a normal, knowing it will be perpendicular, it's going to be positive, and 4 is like 4/1, so we're going to create 1/4. All right, so our first steps will be the same. We will have to get the derivative to find the slope of a tangent, then we're going to mix it up, find the slope of the normal, and back to proceeding, well, let's say as normal. All right, so it's always about reading the question, putting little reminders to yourself that you're going to have to do some extra stuff. So you're looking for a perpendicular slope. So I'm reminding myself over here because I classically forget to get a normal. I just proceed with a tangent. So like I said before, let's just get the point sorted so we don't get lost in our work. When x is equal to 1, y is equal to, so I'm just finding f of 1. 6 over 1 plus 1 is 2 squared equals 6/4, which is the same as 3/2, or 1.5 if you like those decimals. There it is. All right, so we're going to take our equation, f of x, and find the derivative. F of x is equal to, I don't want to use a quotient rule, I guess you could, but I don't feel like it, so I'm going to change it to just 6 on to x squared plus 1 to the power of -2. I'm in for the chain rule, but not much else, so I'll just do my long form of the chain rule so we get some extra practice here. The inner function, let's call it u, is x squared plus 1, which means it has a derivative of 2x, and the outer function will be 6u to the -2, which means it has a derivative of -2 u to the -3. If I rewrite that in terms of x, I get -2 x squared plus 1. Why did I put it on the bottom? Because it's to the power of -3, so it will be a reciprocal with a positive exponent 3. Am I done? No. Remember, you have to gather those all back up. They all are a part of the overall derivative, and we're going to have just going to back up for one moment. I realized that when I did my v prime, I took a 2 in front, but I forgot I had a 6 there already, so this should be a negative 12. There we go. And we are going to combine those two, u prime and v prime, and we're going to get negative 12 times 2 is 24. So here and here, x negative over x squared plus 1 cubed. All right. Don't bother trying to flip this. Just get what the slope of a tangent line is, the actual number. So I'm going to sub in the number 1. Negative 24 times 1 divided by 1 plus 1 cubed, which is negative 24 divided by 8 equals negative 4. Let's label this. This is the slope of the tangent. Just so we don't take it with us, we need the slope of the normal. So we are going to take that negative 4, we are going to find the reciprocal by inverting it, 1 over 4, and when it was negative, we make it positive, so there it is, we're done. The equation of the normal at the point 1, 3 over 2. I like myself some point slope form. We're going to start with y minus that 3 over 2 is equal to the slope onto x minus the x of our point 1. This is correct. If you prefer y equals mx plus b slope intercept form, we can distribute the 1/4. Also, we moved over the 3 over 2, and we finish with y equals 1/4 plus 1/2. No, it doesn't. We'll erase that 1/2 and we'll reconsider our fraction math. Y equals 1/4, so we have negative 1/4 plus 6 over 4, which should give me positive 5 over 4. Woo. So to summarize the process, you're going to be given an equation. Maybe it'll be at a point, or maybe it'll just say when x is equal to. So make sure you find the actual point on the graph by subbing in that x value to get it. And then you're going to take the equation you were given, the function, and you're going to differentiate so that you have the derivative. You're going to put in your x-coordinate and then solve for the slope of a tangent at that point. This should be a number. If you need the normal instead, make sure you take an extra step and find the negative reciprocal of that tangent slope, which means you've turned it into a normal slope, a perpendicular slope. And then finally, you're just going to write a line equation in point slope or slope intercept form. Oh, I didn't finish typing. Using the coordinates of your point and the slope you just found. That's it, that's all. It's a brief topic.